Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see such an interesting topic, like I said in the last video of chemistry. Same, it is going to be very interesting. It is going to be the first lesson of physics, that is electrostatics. If you are seeing this lesson's name in the point of NCRT, CBSE, then it will not be the name. It has some other name. It has a different name in NCRT, something like electric field intensity, like that. I don't know the exact name actually in NCRT. In our NEET syllabus or in MCQ syllabus, this is said as electrostatics. Okay, the first two lessons which are available in NCRT are collectively said as one lesson, that is electrostatics. This lesson is the basic. It is the basic. It is one of the most important and very basic of the total 12th, I can say, because a lot of concepts that you are going to study here in detail will help you, or yes, it will help you to build a foundation in the upcoming lessons. And also it is such an interesting lesson, as I've said. So let us get started. Electrostatics. What does this word mean? What does electrostatics mean? See, the word electrostatic itself says, actually this is kind of a big lesson, so yeah, we will have a lot of pages here. I have 3 PDFs, but don't worry, the rest of the 2 PDFs have only 2 pages, okay? Electrostatics. So what does it mean? Electro, the word electro means charges, static means rest, okay? Dynamic means in motion. So the exact opposite term of electrostatic is going to be electrodynamic. See, when charges are at rest, see, electrostatic is there now. So you have to split it into 2 parts. So this first part is going to be charge. It represents the charge, and the second part represents the motion. Okay, it means the rest. So charge is actually of 3 different types. Actually, I should have left a place to explain, but it was the very first PDF itself that I've created as physics first lesson only. So I didn't have any basic idea. All my point was that I have to write everything big. Okay. So see, charges. If in case charges are at rest, then we say that one as electrostatics. That means in this entire topic, in this entire lesson, we are going to deal only when charges are at rest. Okay, if charges are at rest, then that will be coming into this topic. When charges start to move, okay, in that time we start to study about magnetic field and then also current. Here we will be studying only the electric field. That's it. Only about the electric field and then the basic characters of charges in this lesson. So charge is actually of 2 different types, and motion is of charge is also of 2 different types. Charge is actually of 2 different types, and also motion is also 2 different types. First is negative, second is positive. Motion is actually rest, and then at motion. I can say instead of motion, I can write here movement. Okay, so movement is actually of 2 different types. So that is what I have written here. Charge is actually of 2 different types, and then their movement, the charge movement is also of 2 different types. So first, coming to thermodynamics we have studied, right? Like that. Here we are going to study about electrostatics and about electrodynamics. Electrostatics, it is the rest, and electrodynamics, it is about motion. So charge is actually of 2 different types, as I have written here. First is going to be positive and second is going to be negative. And we all should be positive in order to live a successful and a very happy life. And also charge is a very basic property of every matter in this world. It is also said as, the very basic word is there, right? This basic property can be also said in English as intrinsic property. What does the word intrinsic mean? It means an internal property, a property that is built with the matter when it is being created itself. When a matter is being created, in the time itself, this will be there. Okay, they both are just like twin brothers. See, charge is completely dependent upon these three things only. In this, neutrons will not come. Charge is completely dependent upon these two things only. First will be electrons and second will be protons. So, if an object is having, it can be any object, and if that object is having the count of electrons, the number of electrons higher than the number of protons, then automatically it will be negative. So, when this isn't that important, I've written there. So when the count of electrons, that means number of electrons is higher than number of protons, then automatically what it is going to be a negatively charged body. Okay, then when will it be positively charged body? When will it be positively charged body? It is very simple and very basic, that when number of electrons is lesser than number of protons. That means number of protons is greater than number of electrons. Then in this case, it will be positively charged body. Okay. That's what I have written here. If in case electrons are there, then that is negatively charged body. If protons are there, then that will be positively charged body. Then what about neutrons? We have seen that there are 3 subatomic particles. Those 3 subatomic particles are those which constructs an atom. Okay. Here, neutron is something that represents just the mass. It represents just the mass. Okay, and the charges are being represented by protons and then electrons. So, now we will just give a very basic idea about these electric fields. Okay, see, first, negatively charged body. Any negatively charged body, their electric field. What does it mean? Electric field means, it means for anybody, for even for human body, I'll be saying this we will not be studying anyway, just some basic idea that you can learn. Anybody it can be. So, the structure that you are seeing, right, that means the physical structure that you are seeing, right, more than that there will be the energy levels. That means for a human body, his or her energy levels will be extended from the human body about 6 to 5 feet. It can be 3 feet or it can be 6 to 5 feet also. So that is the particular range where that 6 to 5 feet that is being extended from the human body is there. Now, so that area away from the body is what known as electric field. Sorry, that is what known as field. Okay, in general it is what known as field. When it is happening with a charged body, then we will be saying it as electric field. That means, see, this is what a normal body is actually. A normal body. So a normal body is going to be like this. I will be taking it as a positively charged body since I am a positive person. Here, what is going to happen is, since it is a positively charged, it is a charged body, there will be some amount of field that it is going to produce. Some influence that will be producing around its surroundings. Okay, this charged body will be producing some influence in its surroundings. Okay, and that influencing area will be said as electric field. That particular area which is being influenced by a charged body is said as electric field, and that particular field is represented by electric field lines. We will be studying very in detail with the formula about what is electric field. So that is what. So electric field lines of a positively charged body will be outwards. See, they are being extended outwards. They are being extended outwards, and they will be straight only. They will not be like curve at all. They will be exactly straight only. And for negatively charged body also, they will be straight. They can be also curved. Okay, they can be also curved. There is no problem with it. But when it is just a single body, then it will be straight lines only. So when will they be curving? They will be curving when another charged body is being introduced to them. That means, see, Have you ever noticed that why a magnet is attracting another magnet only with some particular distance? For an example, I can say that even this board is okay. So this is magnetic pen only. This is magnetic stylus only. This part is magnetic and this metal is magnetic. If I am keeping here this, okay, so you cannot see that, right? Okay, so this is magnetic, and let me take a metal. It can be any metal. I don't have a metal. Perfect. Okay, so I'll be keeping this as a metal. Okay, and this as a magnetic. Okay, so from here, this is not being attracted. This metal is not attracting this magnet. But when I take it closer, 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 then automatically, in a particular distance, it attracts. Okay, but so the gravitational field attracted it. So the gravitational field attracted it. Like that only. So when a particular distance, with a particular distance, when it attracts, because the magnetic field around one magnet and the magnetic field around another magnet should coincide. That means they should be interacting with each other. When they start to interact, in that time there will be a pulling force. Okay, two magnets will start to pull each other, and automatically they will be attracted. That is what actually happening. And that will not happen if their distance is very high, because the pulling force is inversely proportional to the square of the radius or square of the distance. It is known as inverse law. In Coulomb's law, we will be studying about it. Okay. See, when a positively charged body and when a negatively charged body are kept together, then this positively charged body's field lines will be attracted by this negatively charged body. So here also it is the same only. When a positively charged body and another positively charged body is kept, in the time the electric field from this positive body will be deviated outwards. Here also it will be deviated like this. That's what is happening. Here is some given data. So this data says about the charge of electrons, charge of protons, and also mass of electrons. Before that, you have to know what are these two. So E, see, charge can be represented with the two terms, E and Q. Okay. In electrostatics, that means when a charge is at rest, then it will be represented with Q. When a charge is at motion, that means electrons are moving, protons are moving, then we will be saying it as E. Okay, see Q. To remember it, we have a shortcut. When you will be standing in a queue, you will be standing, right? So that means you will be stable, you will be stationary only in that particular point, because you are in a queue. So it is at rest. So E means that you are moving. You can just take it as the vice versa case. See here, E of electrons means, see, since electrons will be always moving in an atom, I have written there E of electrons. That means charge of electrons is going to be minus 1.6 into 10 to the power of minus 19 coulomb. And Q of protons is going to be plus 1.6 into 10 to the power of minus 19 coulombs. Make sure that you put here minus and here plus. Okay, that you are going to put. Okay, that you are going to put here minus. For protons, for protons you have to put plus, and for electrons you have to put minus. And to the power, it has to be always none of those dons. Okay, only those great dons will be changing this power into negative, from negative to positive. We cannot do like that. Okay. Next is mass of electron. So mass of electron is going to be 9.1 into 10 to the power of minus 31 kilograms. So now characteristics, a charge is additive in nature. What does it mean? For an example, it can be any body. In a body, there are charges. Okay, there is charge. Now, how will you represent it? For an example, I can take. So this has a body. This body is having different amount of charges. Here it is having negative 3 charge. Okay, here it is having positive 4 charge. Coulomb should come. Okay. Then SI amount of charge is going to be coulomb. We will be studying about stat coulomb. We will be studying about all types of coulombs. Okay, 2 types of coulombs. MCG's unit we are going to study. Then here is minus 5 coulomb. Here is going to be plus 10 coulomb. Now, what is the total charge of this body? In that time, what you are going to do is you are going to add every charge. Minus 3 coulomb, then minus 5 coulomb, plus 4 coulomb, then plus 10 coulomb. So it is going to be minus 8 coulomb plus 14 coulomb. So it is going to be 6 coulomb. Okay, ma. 6 coulomb is the answer. And also, charge is a vector quantity. Make sure that you are knowing this. Charge is a vector quantity. Okay, do not forget. Now, units and dimensions of charge. Okay, units and dimensions of charge. And about dielectrics, we are going to study. Then the history, that means it's kind of going to be kind of sleepy. So you can take your snacks and you can listen all these concepts. That means it's going to be that easy. So first is units. So unit of charge, I don't think you all can see this that clearly. Okay. Now it's perfect in size. See, SI unit of charge. What is the SI unit of charge? SI unit of charge is going to be Coulomb. This is a very well known fact. Okay, from our class 10, we are studying that SI unit of charge is going to be Coulomb only. Now, Siege's unit is alone classified into two types. Okay, Siege's unit depends upon the type, whether if the Siege's unit, if it is dynamic, if we are studying in electrodynamic, then the Siege's unit for electrodynamic will be different, and the Siege's unit for electrostatic will be different, and they both are having a relation also. See, the Siege's unit in the case of static, that means in electrostatics, is going to be stat coulomb, okay, or it is going to be ESU, electrostatic unit. Electrostatic unit, you can say. In the case of dynamic, that means the Siege's unit for dynamic is going to be EMU, electromotive unit only. Electromotive unit, huh? Yeah, something like that only. Or it is going to be AB Coulomb, which is absolute Coulomb. And the relation between them is that 1 Coulomb is equal to 3 into 10 to the power of 9 stat Coulomb, which is further equal to 1 by 10 into absolute Coulomb, AB Coulomb. Make sure that you know this relation. It can be asked in your examination as 1 mark question. What is the relation between stat Coulomb and absolute Coulomb? Or also they can ask it as divide stat Coulomb, divide absolute Coulomb by stat Coulomb. That means what is it going to be? It is going to be 3 into 10 to the power of 10. When you are dividing absolute Coulomb by stat Coulomb, then it is going to be 3 into 10 to the power of 9. Okay, Now, numerical tips and tricks. Here, if you are knowing these values, then no one can beat you in numericals. If you work correctly, okay? If you do hard work correctly in numericals. Personally, I'm very weak in physics numericals. I don't know why I'm having a lot of hard time in physics numericals. We all have to work together. First is millicoulomb. So what is this millicoulomb? Millicoulomb is going to be 10 to the power of minus 3. That means millicoulomb can be said as coulomb into 10 to the power of minus 3. Then it is going to be microcoulomb, which is going to be 10 to the power of minus 6 coulomb. Then it is going to be nanocoulomb, which is going to be 10 to the power of minus 9 coulomb. And at last, the relation that I have said now, absolute Coulomb by stat Coulomb, that means this 10 will be going here, stat Coulomb will be coming down to the denominator. From the denominator, it will be going to the numerator. At last, you will be getting it as 3 into 10 to the power of 10. Perfect. Now, history of charge. So, what history does it have? What is the history lesson that we are going to see? In the case of charge. See, many years ago, once upon a time, there was a person. It seems he had a breakup with someone. I'm just adding these contents. These aren't given in books. These are something that I'm adding so that lessons will be kind of interesting. So he was walking in the sea, since he is suffering from breakup after all. In the time, he saw an amber. He was able to see an amber. What is an amber? Amber is a resin. What is a resin? Resin is an excretory product of a tree. What is an excretory product? It is the nitrogenous waste that is created by an organism. In biology, you will study. So he was able to notice an amber. And since it was kind of good in looks, where was he walking? What was the sea? It was known as Baltic Sea. Very famous sea it seems, but I've never heard the name. Still coming to this history lesson. So what he did is, it fell on the ground. So he had taken it and he had a silk cloth. It seems he is a very rich person that he is able to wipe that amber with silk cloth. He has started to wipe it with that silk cloth. Then what happened is that amber started to get a charge. And that silk cloth also got a charge. This is how first they have found what is a charge is. And later scientists have done some experiments. Scientists have done a lot of things that they can do, and they have found what is the charge and properties of charge, all those things, and those experiments were done by Faraday. And the person who had rubbed it with the silk cloth, that is unknown. I don't know who is it. I cannot find that person's name. If you are able to find it, then please comment it in the comment section. So the person who had rubbed it with the silk cloth, that is unknown. I don't know who is it. I cannot find that person's name. If you are able to find it, then please comment it in the comment section. So in the Baltic seashore only all of these things is happening actually. When it is being rubbed, in that time amber is getting positive charge and then that silk cloth is getting negative charge. Okay, always remember that silk will be getting always negative charge only, and wool will be always getting positive charge only. How can you remember it? Positive means warmth. Automatically what comes to my mind is that positive means warmth. That means during the winter season and all, what we'll be using woolen cloths only, so that we can cover our body and then it will be giving us warmth. Like that you can remember. Ebonite, okay, ebonite, amber, all these words are starting with vowels and somehow they are giving me a negative feeling. So you can see that they are going to get a negative charge only. Glass, okay, just look at you, how beautiful you are, how cute or how handsome or how gorgeous you are. So you are going to, when you are looking at the glass, you are the one who's being reflected, you will be having positive character. So you can remember like that. So it's going to be a positive one. Yeah, like that only. Okay, so here is where we are going to study a lot of things in deeply, but if I say that here itself, then you will be having some trouble with understanding them. We will first come to dielectrics, then we will go to that particular concept, and again we will be coming to quantization of charge. What is a dielectric? Dielectric is a material which is an insulator. It is an insulator only. It will not gain any charge until and unless you are rubbing it, okay, with a cloth or with something, okay. After rubbing with friction only, it produces charge. And also note that all dielectrics are insulators, but not all insulators are dielectrics. Okay, so this is something that you have to know. So people, okay, a lot of people have got a doubt. Why? What's the reason that this material is getting positive charge? Okay, why this material is getting positive charge? Why this material is getting negative charge? Okay, that we will be studying in the formation of current. Okay, so before that we will be studying quantization of charge, and then we will be studying this node point. Then we will be coming to that doubt. A lot of people can have that doubt, so it can wait for some time. It has to wait. What is quantization of charge? If you guys have seen a lot of movies, I'm not that much familiar with movies, mainly with English movies. I like only my mother tongue movies. They are very easy to understand comparatively with English movies. But my brother he just loves them just like that. So in a Ant-Man movie, it seems they have used quanta something. There is a mission. That mission is what helping Ant-Man to convert into that small sized being where he can fly in the speed of light or with high speed. Okay, so that particular mission is there. Now that word quanta, what does it mean actually? If you are a person who is interested in science, just like young Sheldon, I'm not like young Sheldon, not even a bit, complete opposite. So if you are interested in science, then you would have researched about quanta. Quanta means smallest, tiniest, teeniest particle in this overall world, which is going to be electrons and protons. So quantization of charge, that means if you are taking a big mass of charge, I can take this itself, this note. Okay, I've taken this note. Here is what this note is. This note will have some charge definitely, but this is neutral because positive charge and the negative charge in this are being cancelled out. So it is actually neutral at present. Protons and electrons are equal in each other, so it is actually nil charged. So what I'm coming to say is this body is having some charge. If you are breaking that charge from 10 charge to 9 charge, 9 charge to 8 charge, like that, if you are breaking all the charges, at last you will be fixed at a particular point. And that point is like this, it collapses. Okay, so that particular point is what quantization of charge. That means you are breaking the finest, till to the finest part you are breaking it. So what is the finest part? It is going to be the charge of the proton and the charge of the electron. It can be either of them, any of them. That is what it means. That means the total charge in a body, the total charge in the body is equal to number of electrons and number of protons. When you're adding these two, then you will be getting the total charge in a body. So Q is equal to plus or minus NE. So plus or minus N. What does that N mean? N means any natural number. That means total number of electrons or total number of protons. A lot of people are thinking that this N is an integer or N is a whole number. It is not an integer. It is neither an integer nor a whole number. It is a natural number which starts from 1 and it ends at the infinite. Make sure that you remember this point. And this plus or minus is not something that is because of this N, it is because of the charge. Here I have written E now. So instead of E, I can also write Q over there because, see, what is the charge of a proton? Charge of a proton is going to be positive only. So this positive is coming from E because charge of the proton is positive. What is the charge of electron? Electron is negative. So this negative sign is coming from E because electron sign is actually negative. That is what it means. And also I have said that charge is additive already. We have seen one numerical here now. So I have just added these charges which is in this body now. I'm using the word na a lot now. Okay, I'll reduce it. So I have added all the charge which is in this body and I've got one particular resultant charge. That particular factor is known as charge is additive. Okay, you can just add charge just like that. Actually, charge is a scalar quantity. If something is additive, then that means it is a scalar quantity only. And the magnitude of E value is always constant. That is going to be, no matter of what, modulus of E value is going to be 1.600 into the power of minus 19 coulombs. And this plus or minus will be differs. Next is node point. See, we have seen law of conservation of energy. That means energy can neither be destroyed nor be created. So it is said with the example of a radon of 88th element of mass number 226. See, when you are hitting this neutrons, okay, these neutrons of radons, then this neutron will be split into electrons and protons, where electron will be having negative charge. See, this denominator part is there, right? This subscript is there. Now that represents the charge and the superscript represents the mass. So here I'm having negative charge, here I'm having positive charge, and here I'm having 0, here I'm having 1. What does it actually mean? It means the charge of electron is -1, charge of proton is +1, and mass of electron is 0, and the mass of proton is 1. So when you are adding subscript with subscript, that means, see here -1 and +1. When you are adding it, it gives you 0. So it is here also 0 only because the charge of neutron is 0, and when you are adding the charge of electron and charge of proton, it also gives you 0. And here, the mass of this neutron is going to be 1, mass of electron is 0, and mass of proton is 1. When you are adding electron plus proton, it automatically gives you the mass of neutrons. Wow, how good is it? Next is charging methods of a body. With this, we will end this first part. I know this is kind of heavy. This is what the basic thing is. Hereafter, every law, every derivation is going to be very, 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 very easy. Easy peasy lemon squeezy. Okay. So what is the charging method? Charging method is the frictional. First, you can actually charge a body with based on 3 different types. Within 10 minutes, the video will be ending. So charging method of a body. See, you can charge a body with 3 different types. First is going to be frictional method. That means when you are rubbing a body with a particular item, with an item, then automatically it gains charge. It gains some amount of charge. Then that means what? That is what actually said as frictional. How is this happening? What is the mechanism? Here you have to study about work function. What is this work function? Work function is the minimum amount of energy that is required to liberate an electron. That means some amount of energy is required for every item in this world in order to liberate some amount of energy. Okay, see. I don't think this is in our NCERT book, or neither most of your teachers will have said. Since it is a seminar, you can learn a lot, I think. Work function, that means, see, for an example, I'm going to take a negatively charged body. A positively charged body. Let this be the amber. And there is this silk cloth. Okay, this is what the silk cloth is that has gained a negative charge. Why has it gained the negative charge and why has it gained the positive charge? It is because this ebonite is actually having so this ebonite is actually having all the negatively charged bodies having high work function. Okay, this ebonite is having less work function. Okay, and this is having high work function. I have written here even if work function is high, then automatically they will be negatively charged body. If work function is less, then they will be automatically positively charged body. So instead of work function, it's very simple. It's very, very simple. Let us just correlate it with our own real life. You are doing a lot of work, then absolutely your energy level will be negative because all your work you have done. So energy is being lost. It has been lost. And you are doing less work function. That means you will be having a lot of energy inside you. That's what it means. Actually, it doesn't mean that thing. Just I'm giving you a life example. Actually, what it means is the amount of energy that is being liberated should be less. That means in order to get one electron from a body, I have to give less energy itself. That means very easily that body has to liberate electrons. This glass rod is there now. This glass is actually having positive charge because it is able to liberate all the electrons very easily comparatively with silk. So all the liberated electrons from this glass will be going to this silk. So that says that the silk is having high work function, that is why it is actually negatively charged body, and this glass is having less work function, that is why it is having positively charged body. This is what it actually means. Here it is able to liberate all the electrons very easily because of its work function nature. Here less work function. Okay, so that is why it is able to liberate all the electrons very easily with less amount of energy even, and that energy is being produced by the frictional force. The force that you are giving while friction while rubbing that is what it is. That is what it is. Next is going to be conduction and then this induction. What is this conduction and what is this induction? Conduction is very simple. You are actually having a body. Okay, you are having this a body and you are having another body. First you are having a charged body and you are having another conductor that is not charged. It is just a conductor. That means let us keep this one and I will take this marker. Okay, there are two markers. This is charged. Okay, this is very handsome. This marker comparatively with this. So this is charged and this is not yet charged. So since it is charged and it is a conductor, when you are actually having contact with this one, then automatically this conductor will also become charged. Here flow of electrons happen. Here it is electrodynamic. Here it is not electrostatic. In this case and here in this case, it is actually electrodynamic, not electrostatic. Next is induction. What is this induction? Actually, in superhero movies or in supernatural movies at all, just by staring itself, there will be a power, there will be a charge, will be created in somewhere, just like staring. That is what here also. Just by looking itself, it's enough for a body to get its charge. That means, see, this is a neutral body. Okay, this is a neutral sphere, I can say, and here I'm having a charged sphere. Okay, here I'm having a positive charged sphere. So what will happen? All the negative charges will be attracted towards this sphere. That means, see, all the negative charges are attracted here, and all the positive is already here. So all the negative will be here, and the positive, all positive charges will be repelled to the opposite direction. Now what we are doing is, we are going to remove all these positive directions and positive charges, and we are going to give it to our Mata, to our Mother Earth. Okay, to our Mother Earth, Bhumi Mata, we are going to give all of the charge. Let you can keep the charge we don't want, and we will be having only the negative charge. We will be having only the negative charge. Always remember, this can be asked as 1 mark question. If a positive sphere is there, then negative object only you can create. Negatively charged body only you can create. If a negative sphere is there, then the positively charged body only you can create. Okay, done. Super pakka. And here is some question. Okay, in this process, no charge is being lost. But you can have a doubt that, see, here I'm losing this positive charge now. I'm giving it to Earth now. So that means in this process, positive charge is being lost. But why? Why aren't we saying? Why aren't we saying that here charge is being lost? Why are we saying that charge is not lost? It is because when you are giving any charge, when you are giving a charge to Earth, then it will not be considered as loss or loss. Yes, it will not be considered as loss of charge. There won't be any charge loss if you are giving it to our Mother Earth. Only if you are giving it to other particles, then it will be considered as a loss of charge. If you are giving it to Earth, we will not say it as loss of charge, because the system, okay, in thermodynamics, you would have studied about the system, you would have studied about the universe, you would have studied about the surroundings. Here, surroundings is excluded from Earth and that object. That means here the system is going to be sphere and Earth. Since you are combining sphere and Earth as a system, that means it is what the total object itself. So the total object that you are actually earthifying is this one only, with Earth, that particular body with Earth. Okay, so I hope you have got it. If you haven't got, if you don't get that last point which I've said, then just remember that any object, it can be any object, no matter what. If it is giving its charge to our Mother Earth, then we will not say it as loss of charge, because it is going to our mother only. It will not be loss. Okay, just remember this point. If they are asking why in your examination, you can just simply write this one, sphere, okay, or that object plus Earth, you can just by heart it and you can write, and you can say that Earth is the reservoir of charge. That's it, you will get your marks.